All right, here we go. Defining functions of two variables, 4, 6. And so what we've got here, it says you're going to be probably fairly familiar with this idea. You've dealt with things like perimeter, and perimeter equals 2 times the length and times, or sorry, plus 2 times the width. If you got a rectangle, for example, and it's specifically perimeter of a rectangle, then you're going to have 2 widths and 2 lengths. So this length here plus this length here, 2 times L, perimeter equals 2 times L plus this width plus this width is 2W. And so you're familiar with that. And we're just going to be a little bit more explicit and technical kind of about these ideas. And actually, let's go and just leave that on there. So how we are going to write this is that the perimeter is a function of the length and the width. And that function is 2 times the length plus 2 times the width. And that kind of emphasizes in the functional relationship that the function of P is based on L and W, so the function of L and W. Now, the total surface area of a cone is given by this area here. So the area of a cone, and you can kind of think of a cone shape here. We're going to have the surface area of the base, which is the radius squared times pi, and then the radius of this, the rest of the cone here. That surface area, that lateral area, is pi times the radius times the slant height. So the slant height is the length down the side. Now, the total area is a function of what two variables? And hopefully you can see it's R and L. Now R appears twice, but that's okay. We've got two different variables that area is going to be defined by. And so we've got area equals, and area A of R L is going to be equal to pi times the radius squared plus pi times the radius times the slant height. Okay, so based on us knowing that this is the function of A, the function of the area, now we want to show that same function, but now instead of R and L, we're going to be plugging in 2R and 2L, show that it's equal to that same function times 4. And let's take a look at that if that's even true. So first off, if I have 4 times the area of 4 times the area, I'm going to do this part right here first because I think it's a little more straightforward. We've got 4 times, well, what was the function of area? It was pi r squared plus pi r L. Okay, and all we've done is taken that same function as before and multiplied it by 4. That's what's going on here on the right-hand side. Now on the left, we're doing something that should be familiar, but just want to be careful about it. We're evaluating the function, but plugging in, instead of R, we're plugging in 2R, and instead of L, we're plugging in 2L. That's going to be the R and L values for this function right here. So we've got pi of R squared, but instead of R, we're plugging in 2R. And then that plus pi, and again, instead of R, we're plugging in 2R. And instead of L, we're plugging in 2L. And now we'll just kind of have to go through and evaluate it. So, or solve and show that solving is not the right term there, but evaluate it and show that they are in fact equal. So let's slide over to the right a little bit. And we'll switch colors here. So pi times 2r squared. Well, 2r squared, that's 4r squared. So pi 4r squared plus pi times 2r times 2l. That's going to be pi times 4 times, what is that, RL? RL. And actually, let's change that up. No, because normally we'll have 4 as the coefficient up front. So 4 pi r and then 4 pi RL. So all I did was switch the pi and the 4 there. Equals, and kind of more does it equal, and hopefully we see that it's going to. And so distribute our 4 pi r squared, and I'm dealing with the right hand of the equation here. 4 pi r squared plus 4 pi RL. And hey, these are the same. 4 pi r squared, 4 pi r squared, plus 4 pi RL, 4 pi RL. These are the same, so they are, in fact, equal to one another. So we've shown now that, yes, this is true, that the area of 2R, 2L is equal to, or the function of A when R is 2R and when L is 2L is equal to 4 times the function of A when with R and L. All right, hope that helped.